This is the Pearson Edexcel IGCSE Further Pure Maths Paper 1R from June 2022. Let's just do it. Got some information about arithmetic series in the formula book, but really all we need to know is that it starts with the term A, and then you add on some number D, and then you add on another D to get to the next, and then another D, and it just looks a bit like this. So the fifth term, 1, 2, 3, 4, 5, is A plus 40, so that's equal to 16. And the 100th term, well, of course, if the fifth term is 4D, the 100th is going to be 99D. Just because the first one just doesn't have a D next to it, so it's just always one less. That's 301. Do this, take away this, you get this, divide by 95 for this, and then substitute it back in for this. And then the 50th term, the sum of the first 50 terms is just using this formula, so S of 50 is 50 over 2 times 4 plus n minus 1, or n was 50, wasn't it? So that's going to be 49 times 3, because that's what D is. You put it in the calculator, you get this. That's our first warm-up question done. When we're doing stuff like velocity, and you've been given it in terms of t, if you differentiate that, you get the acceleration. So the acceleration is dv by dt, which is just 2t minus 3, and that's as simple as that. And the displacement is given by integrating velocity. So let's just integrate this. I'll call displacement s. Just integrate these three terms, and of course add in a c. And we have this initial condition here. S is 7 when t is 2, so substitute that information in, and we'll solve for c as this, and then we'll write it out like this. And then it says find that displacement, so find this value s when t is 4, so substitute 4 into here, and type that in a calculator, and you get this for our answer, which is good. Question 3 then. So the area of a sector, if you're in radians, is just r squared theta over 2. That's not in the formula book, unless I was just being blind. You're given the area as 2 pi, so 2 pi equals this, r is 4. So 4 squared is 16, divided by 2 is 8. And then divide this by 8, you get pi over 4 for theta. Find the perimeter of this whole thing. So the arc length, again in radians, is just r theta. So this arc, rs, is just r, which is 4, times theta, which is pi over 4, which is just which is just pi, of course. Pi over 4 times 4 is just pi. And then we add in this 4, because we're looking for the perimeter, which is all the way around. And it's just pi plus 8, which I think is this as a decimal. And now this point here lies on a ratio 1 to 3. So this bit is 3 times longer than this bit. Well, if this is radius 4, then that just means this is 1 and this is 3, I think. Now, to work out this grey area, we can just do the area of the sector, which is, what was the area of the sector? 2 pi. And we can just take away the area of this triangle, which we can do by just doing a half AB sine C. So a half times 1 times 4 times sine of theta, theta being pi over 4. Sine of pi over 4 is 1 over root 2. This makes 2, so that's 2 times 1 over root 2, which I think is just root 2. And then we just do 2 pi minus that root 2. And we'll end up with the answer exactly. Question 4 then. So the perimeter is just this times 2 plus this times 2, which is that, which simplifies to that. Sorry about that. The area is just, of course, this times this. Now, the perimeter is less than 30, so that there is less than 30. The area is greater than 12, so that's greater than 12. This is very easy to solve pretty quickly, and we'll get x is less than 11 over 2. This one, expand out and move the 12 to this side. Lots of ways you can solve quadratic inequalities, but if you just find the critical values by maybe factorizing, critical values at minus 6 and 2. If you want to be greater than 0, you want to be either side of those. So x less than minus 6, x greater than 2. Now, x can't be less than minus 6 because then these sides don't make any sense. They're negative. So just ignore this. So x has to be bigger than 2, but it also has to be less than 11 over 2, and that gives us our bound right there, and we're done. Question 5 then. So using some product rules to differentiate this, if we just call it f of x. Product rule says to differentiate the first function. Differentiating this just becomes 4e to the 4x, and leave this function alone. So that's what I'll do first. So that's this one differentiated, this one left alone, and then leave this one alone, and differentiate this one. Chain rule says to move this 3 over 2 down to the front, which is there. The derivative of the inside is just 6, so that's there. And then you keep this the same, lower this down by 1 to get to a half. And I just got some sorting out to do. 6 times 3 over 2 is 9. We can factorize out an e to the 4x from that to make this. And then we can factorize out a 6x plus 2 all to the power of half. And what that does is it leaves behind 6x plus 2 to the power 1 here at the front, because this to the power half times this to the power 1 makes 3 over 2. You add the powers. And of course, if we factorize that out to the front there, we just leave behind nothing. So we just left with this 9. Of course, 4 times 6 is 24, plus 8 plus 9 is 17. And I think we end up with this. Of course, this can be written as root of 6x plus 2, which is how they wrote it just there. For the next one, you could use quotient rule, but people who watch my channel know that I won't be doing that. I'll just be writing this as this to the power minus 3 and putting it on the top. And then I'll just use some more product rules. So the derivative of this is 3 cos 3x, because sine differentiates straight to cos, and you end up with this, leave this alone, and then leave this alone, and differentiate this. Same thing, so the minus 3 comes out to the front, which is there. The derivative of that is 2, which is there. This stays the same, or to the power minus 4 as you drop it down by 1. And it doesn't say to do any simplifying at all, so I think this will be fine. But it would be sensible at least to group those two up, I guess. And you end up with that there. Question 6 is just rationalizing the denominator. So times this thing here by root 5 plus 2 over root 5 plus 2, just the conjugate, and then start doing some expanding. So 8a root 5 plus 2a plus 5 plus 2 root 5 is this top bit. And then, of course, root 5 times root 5 is 5, minus 4, and then the cross terms will cancel by design. This just makes a 1, which is very convenient. Apparently that equals that. We can just compare terms here. We've got a root 5 plus 2 root 5 makes 5 root 5, apparently. Well, that means a must be 3. And you can check that 5 plus 2 times 3 is also 11, so that's good. Triangle PQR is this. I've just drawn it, so I think I've got all the information right. PR is this, QR is that. QPR is 30, and then PQR is 45. Just do some sine rule. This over sine that equals this over sine that. Sine 30 is a half, so dividing by half is the same as times by 2, so that will become like 2x. Sine 45 is 1 over root 2, which is the same as timesing by root 2, so we can just times this by root 2 to make this. Group the x's together and factorize out, divide through, and we get this. There's probably easier ways to do this, I would imagine, but anyway. Then we rationalize this, same kind of idea as we did before. This times this is 6 root 2, plus root 2 times root 2 is 2, so that's times by 3 is 6. And then, of course, 2 and then minus 2, and the cross terms cancel. Sorry, 4 is 2 times 2, then minus 2, and the cross terms cancel. And then this makes it 2. Divide both by 2 and get 3 root 2 plus 3, which is what they wanted us to get. Given that sine 105 is this, and the area is A, show area can be written as this. So we can just plug in this value for x into here now. So we get this, I think. If you just plug in those two values with this, I think you get this. And then the area of this is clearly going to be a half times this, times that, times sine of this. Now, very conveniently, this angle is 105, because 30 plus 45 is 75, 180 minus that is 105. We're told that sine 105 is that. So I think this is all good to go. I've multiplied these two together already, so 18 plus 18 root 2 plus another 9 root 2 makes 27 root 2, plus 9 times 9, plus, and then also root 2 times root 2 is 2, so that makes 18 in total. Combine those together, you can maybe halve them all. Actually, no, factorize out an eighth because of this. You want to get it in the form they want, so factorize out an eighth from there. And then, of course, we can collect this together and then expand it with this. So that's going to be 36 root 6, 36 root 2, root 2 times root 6 is root 12, and then root 2 times root 2 is 2, so that times by 27 to make 54 at the end. So we get all of this. Root 12 is 12 is 4 times 3, so that's root 4 times root 3, which is 2 root 3. 27 times 2 is 54, so that makes this working over here now. And then, of course, we can just factorize out a 9, and I think we get what we needed to get there, and we're good to go. Question 7 then, so sketch this curve. This is just a log curve, which should look like this, asymptoting at the y-axis, and it's been moved left 2 places because of this plus 2, so it's just going to do this instead. This point here is going to be when the y-coordinate is 0, so when that's 0, raise both sides to the power 10, 10 to the power 0 equals x plus 2, which means 1 is x plus 2, and then you take away 2 and you get x is minus 1. I think the other way you could have done it is just you should know that the log graph goes through the x-axis of 1, and you're just moving it 2 to the left, so it needs to be minus 1. And then this point here is when x is 0, just shove in x is 0, and you get log to base 10 of 2 is right there. So that's my sketch. Solve this equation now, so let's just divide everything by 2. That seems like the obvious thing to do first. We can times together the inputs of these logs when they're adding, so this is just log to base a of 64. And then, of course, we can raise both sides to a, so a to both sides, so cancels out this, and then a to the power half. Square both sides now, and we end up with this. Now, this one's more interesting. In the formula book, you have this right at the bottom of it about logarithms right here. What this is basically saying is if you have log to something of something else, you can write that as log to base whatever you want, in this case Taylor, because when would we not use Taylor, of the one here, which is the b, over log to base whatever you want of a. And this can literally be whatever you want. So what I'm going to do is I'm going to turn one of these two logs into the other one. So instead of having log to base q of 16, I'm going to write that as log to base 2, because that makes it the same as this one, of 16 over log to base 2 of this q here. And that's super helpful, because log to base 2 of 16 is just 4, because 2 to the power 4 is 16. And now if I times everything by log to base 2 of q, I get rid of it here, put 2 lots of it here as a squared, and put it over here as well. And this looks like a bit of a quadratic once you divide by 4 and rearrange. It's just a quadratic. It looks a bit like this quadratic. And we know this factorizes to x minus 1, x minus 5. So this must factorize to log to base 2 of q minus 1 into log to base 2 of q minus 5. And then, of course, we just solve log to base 2 of q is 1 or log to base 2 of q is 5. And of course, this one tells us that if you just put 2 to the power 1 up, you get 2. And this one, 2 to the power something, has to be 5. And we get 32 as our answer there. And those are our two answers. Excellent. Thank you, Taylor, for helping us out with that question. Not going to spend much of any time on this, I don't think. It's just binomial expansion. The coefficients go 1, 3, 3, 1. And then, of course, you just swap these numbers around, swap these x's around. So first x of 3, then x squared y1, then x y2, and then y3. So that's good. Quadratic equation is this here. And, okay, so that's good. Has roots alpha and beta. So I'm just going to divide everything here by 2. Just because I prefer doing it that way. And then alpha times beta must make the one at the end, and alpha plus beta must be minus the one in the middle. If you prefer to just keep the 2 there and do 4 divided by 2 and 3 divided by 2, when you're setting these up, you'll of course get the same thing. This is negative just because they're in singles here, whereas if they're doubles, you keep it as a positive. Cool. There are some interesting videos that will explain exactly why that is, but for now I'll just assume that you've been taught to do that. Anyway, find the value of a plus b cubed. So we're going to take this thing right here and we're going to cube it. This cubed is minus 27 over 8. 3 negatives still make a negative. This cubed we just worked out, just with x's and y's instead of alphas and betas. So that's cool. What we can do here is I can write this as alpha times beta times alpha. And this is alpha times beta, because alpha beta is 2. So replace these with 2's. 3 times 2 is 6. So we get this and this again. And then factorize out the 6 and we get this. But we know this is minus 3 over 2. 6 times minus 3 over 2, I believe, is minus 9. Add 9 to both sides, and we get this. And so that will be our answer, because we've got the a cubed plus b cubed just here, which I rescued over there. Hence form a quadratic with integer coefficients that has these roots. There's a lot of things you could do here, but I just said, okay, here's the quadratic I want. And I want this root times this root to be b. And I want this root plus this root to be minus a, just like I had before, because I've got a 1 here. I can do that. But of course, this root times this root. Now, if you just times across, you get alpha beta times beta squared over alpha squared. But you can just cancel some of that down to get this. But alpha beta is just 2, as we've already discussed. So therefore, b is a half. And likewise, the two roots need to add to make minus a. But you can add these together. Times this by alpha squared over alpha squared, this by beta squared over beta squared. Then put them together. You get this, same denominator, so we can just do that. This is equal to 45 over 8. This is alpha beta all squared. So that's 2 squared, which is 4. And then there's 38. This 8 here can just times this 4, but to get 32. And we just get a is minus 45 over 32 because of that minus. So then we can put those into our formula here. We'll get this. And then, of course, if I times everything by 32, I'll make everything nice and integered. And that'll be that done. 9 then is the vectors question. So a to d is this. So let's label this. B to c is that. B to d is this there. Prove a to b. So a to b and d to c is what I'm looking for. Now a to b is clearly just this minus all of that. So be careful with the minuses, but you eventually get this. And then d to c is just what? Or minus this plus this. So again, put out those negatives there and you get this. You just get 1 plus a third is 4 thirds. I think I can factorize out a third from this is probably what I did to get this. And then if you factorize out a half from that, you get this. And now they're both multiples of 12a plus 4b, and they are therefore parallel to each other. The diagonals a and c and b and d, so a and c and b and d meet at the point y. Find a to y. So we need 2 ways of getting from a to y. The first way is you could just do going to b and then going to y. So going to b is just this 6a plus 2b, and then plus some amount of this vector that gets you down to here. I've made a whole video on this before, so I'll put it in the description maybe. But yeah, this is just this vector plus some amount of this vector. Of course, we can expand that out and group the a's and the b's together, and I think we end up with this. And now we could also describe a to y by saying, well, a to c is just this plus this, right? So a to c is just that plus that. Put those together and you get this. And now a to y is just, again, some amount of a to c, right? It's just like, looks like 0.6 of it maybe. So it's just some amount, just times it by m, where m is maybe a number less than 1. It's just some amount of that whole thing to get to there. But of course, these two things represent exactly the same vector because they're both a to y. So therefore, this thing here, this amount of a's must be equal to this amount of a's. So we set up this equals this. And this amount of b's must be the same as this amount of b's. So we do that. This is just a simultaneous equation. I don't know what I did here. I can't remember. Did I times this by... I times this by 4. That's a bold strategy. Oh, because then I can do this minus this. This is 18 over 3, so this minus this makes 10 over 3m. And the k's cancel. And you just get 2. Nice, okay. And then you times by 3 divided by 10. And it is 0.6. Wow, nicely remembered. Okay, so it's 3/5. So m is 3/5. We could find k by substituting. You get this. It actually doesn't matter because it wants a to y. And I have an a to y as long as I just put this m in here. And we'll find a to y is that as our answer. Good, we've only got a couple of questions left. So this question here, using these results for sine, which are in the formula book here, do this. Now, this is quite nice. You're allowed to work either left to right or right to left. So I just chose to work right to left. So the right-hand side is equal to this here. And you can write 5x as 4x plus x. And you can write 3x as 4x minus x. I think that makes sense, right? But now just you apply these rules here. So sine of 4x plus x. So replace these with the a's with a 4x and the b's with an x. And you end up with this here. So that's just the first half, I think. And then this half, again, replace, using this formula here this time, replace the a's with a 4x and the b's with an x. And you get this. And very nicely, this cancels straight away with this. And you just get 2 lots of this thing, which is the right-hand side. That's, sorry, the left-hand side, which is very nice and easy. Now it wants us to, this is a sketch of the curve y equals 6 sine 4x cos x. Now that's 3 times this. So obviously we're just going to times this by 3 and probably end up using that. Otherwise they wouldn't have bothered to make us do that in the first place. We want to find the total area bounded between here and here. Now notice they haven't given us any indication of where this is, like where pi over 2 is. So we're going to have to figure that out. So looking at this one here, not this one here, but this way of saying it here. When would this be 0? I'm going to count roots going along. Well, when would this be 0? Well, it's either 0 when sine 4x is 0 or when cos of x is 0. Now, when is sine x 0? Just to ask this question first. Well, that's when x is 0 pi or 2 pi and 3 pi and so on. So when is sine of 4x 0? Well, that's the same points, just all divided by 4, because you'll end up with 4x equals these things, and then you just divide by 4, and you get these things. So I think that's probably pi over 4, and that's probably pi over 2. And that's probably 3 pi over 2, and the next one would be pi. But also, you've got these cos of x's causing zeros. So when is cos of x 0? That would also make y 0. Well, that's pi over 2 and pi and 3 pi over 2 and so on. But those roots just actually end up, because you're dividing this by 4, end up being equivalent to these roots anyway. So when we're counting roots along, the first one is here at 0, then pi over 4, then pi over 2, then 3 pi over 2, then pi. And pi over 2 is therefore here. So that's our first thing to have decided. Now the other thing is looking for the total area bounded. So you can't just integrate between 0 and pi over 2, because then this negative area will cancel with this positive one, and you won't end up with the total area. So what you need to do is you need to integrate between 0 and pi over 4 and get this area. And then you need to also integrate between pi over 4 and pi over 2 and get this area, which will be a negative. You need to ignore the negative, and then you need to add the two areas together to get the total area. A shorthand way of doing this would be to just do it like this. So this is the integral for this area, and this is the integral for this area, sorry, this one here, which I know is going to be a negative number. So if I just take it away, the two negatives will cancel, and it's as if I'm adding this area in. So this is kind of the shorthand way of doing it. Of course, now we can just integrate, really not too hard. Sine integrates to negative cos, divide by 5, of course, because of this 5 here, and likewise, exactly the same stuff over here. Input all of these numbers here, and this would be really nice if this exam wasn't calculator, but it is, which means you can just spend a whole minute of your time typing that entire thing into one, or literally just typing it in like this, or even like this, because what is the point? But anyway, you get this number here. This would have been so nice in on non-calc paper, because you just have to know all these things and do it carefully. But no, alas, Yeah, it's dumb. Anyway, an equation of the straight line L is this. So let's just very quickly draw this. I've rearranged it to be in sensible form. So that's that one there. And now A lies on the y-axis. So that's this point here. That's A. And that's obviously 0, 3 because of this 3 here. B also is on L and has coordinate 10, comma B. Of course, you just put 10 into here and you get 3 times 10 plus 3 is 33. So y is 33 or B is 33. So this is the point B up here somewhere at 10. Let's pretend it's the end of the line at 1033. The point C is on AB, so somewhere between here and here, and divides in the ratio 2 to 3. So to get across from A to B, you have to go across 10. And to go upwards, you have to go up 30 from here to here. So if we split that into 5 parts, that's across 2 up 6 for each part. Across 2 up 6, across 2 up 6, across 2 up 6, and so on. For 5 parts, we want 2 of those to get to C from A. So across 2 up 6 takes us to 2, 9. And then across 2 and up another 6 gets us to 4, 15. And that will be C somewhere in here. And now a straight line K goes through C and is perpendicular to L. So it looks a bit like this, with C here, and this is perpendicular to the first line, which of course means its gradient is the negative reciprocal, which is minus 1 over 3. We can now just use y minus y1 equals mx minus x1, using this is our y1 and x1 here, and this is our m. So that looks like that. We can of course times by 3 here, and then we can just put those together, and we end up with what they wanted us to get. The point D has coordinates PQ and is on, and what's even going on here, such that A to D, so A was here, remember, A to D is parallel to this line K. Remember, K was the second line. So A to D, so D is probably up here somewhere, such that A to D is parallel like this. So D maybe is up here somewhere, the coordinates PQ. So maybe it's up there. It could be down here as well. And in fact, I think we'll find both, but it will end up being up here because Q is positive, so it's above the x-axis. But anyway, length of A to D is 12 root 10. So from A to D, if we go across and up, we need to go across P units, and we need to go up Q minus 3 units. Right, from 0 to this B here is just P across, and from Q up here to 3, that's Q minus 3. So therefore, P squared plus Q minus 3 all squared is equal to 12 root 10 all squared, just by Pythagoras, because we know the length A to D. We can, of course, square that out. 12 squared is 144, root 10 squared is 10. So it's just that. But we also know that this lies, this point D, PQ, it lies on this line, which we know its gradient, because it's parallel to this one, to K. We know its gradient is minus a third, and we also know it has y-intercept of 3. So that's the equation of that line. And so therefore, P and Q follow this rule, because they're on this line. So therefore, Q equals minus 1/3 P plus 3, which I can then just times by minus 3 or something like that and get this. And then I can substitute that into there, and now I can ignore everything about this question, because all I need to do is solve this simultaneous equation here. So let's solve this one for Q first, by expanding everything out. Remember, this is 9 minus 3Q times 9 minus 3Q, expanded all properly, and likewise here. Then you collect everything together. Then you use quadratic formula maybe after dividing by 10, or you just notice that it factorizes, I guess, which is what I did. And quadratic formula would have got it even all the way up here if you just have a calculator. But anyway, you get Q is 15 or Q is minus 9. Now, it told you earlier that Q was positive, so therefore Q is 15. And if Q is 15, you just put it into there to make 9 minus 45, which is minus 36. And so that will be our coordinate of D, which I've now labeled as this. So now I'm just going to take this picture here. I'm going to remove this line because it turns out I don't need it anymore. But D is now just some point over here, which I've now labeled like this, with minus 36, 15 as its coordinate. And these two lines are the lines we've been looking at before, so that's fine. Okay, now it says E lies on K. Now K is this line here, such that D to E is parallel with the y-axis, so it's going straight up. So E is like here somewhere. And if it's going straight up, its x coordinate is the same. Now, if it's on this line, I can work out its y coordinate by just putting minus 36 into this line. And if you do that, you get this. And then likewise, F is on L, so F is on this line, such that DF is also parallel to the y-axis. So F is straight down from D until you end up down here somewhere on this line, which is also got this same x coordinate because it's just going straight down. And then you put that x coordinate into here, and you end up with this as your y coordinate for F. And now it wants the area of the triangle E to C to F. And now what we remember is that these two lines are perpendicular, so this is a right angle. So to work out the area of this triangle, all I need to do is do a half times this length, because they're perpendicular to each other. So, okay, what's the length of F to C? Well, going acrosswards, it's just minus 36 plus 4, or 36 in distance here, plus another 4 in distance to get to there. So that's 40 across, and upwards, it's minus 115 up to here, and then plus another 15 to get to there, so that's 120. Just type that into calculator to get this, and then this one here, same kind of deal. So going across, you need to go across 36, and then across another 4, and you get to here, so that's across 40 again. And then to go downwards, you need to go 85 over 3 minus 15 down, because you've already got 15 going up here. So it's just whatever 85 over 3 is minus this 15 to get this distance down here. Put that in a calculator, and you get this. And then, of course, the area of the triangle is just a half times that length there, which we've got, times that length there, which we've also got. Again, put it in a calculator. You end up with this. That's the entire paper. Thanks for watching, and I'll see you next time.